Welcome to Geometry PAP. This is our first unit in our first section that we're going to do some video notes on. So I would like you to pause this video and try this little warm-up. Try to draw a picture of a point, a line, a plane, a segment array, and opposite rays. And then we're going to compare these pictures that you draw here at the beginning with the work that we're going to do and go over with and see how well you learned what you were doing. Okay, so you should have drawn a few pictures, and so our objective today is learn how to name and sketch all the geometric figures that you see listed here. And we're just going to understand that geometric figures have lots of different ways to show the symbols, and so this is how geometry becomes a different language. So this is kind of how we communicate all throughout the year in geometry. So our first one here is a point indicates a blank and has a blank blank. So we're going to fill in these blanks in this picture. You should have this in your notes packet, and that way you can follow along as we go. Okay, so as we look at the word point, a point indicates a position and has no dimensions. So there's no size to it. There's no big point, small point, large point, fat point, skinny point. So if we look at a diagram, it's just like a single dot, and we always have letters by them in geometry. You weren't used to that in probably in algebra, but in geometry we always have letters by them to give us a way to name them. And so the symbols that we use for points are capital script letters. So this is points A, comma B, comma C. Don't put any dots by them. Don't do anything like that. That's just capital letters listed with commas, and that would represent your points. Okay, and so then we go to the next one, a line. A line is represented by a straight path that extends in two, hold on there, opposite directions. So opposite directions without end and has no thickness. A line contains infinite Okay, so we said infinite many points. Okay, and a plane is, oh, we got to do the picture, I guess. So here's how we got a line here. All right, and so we're going to have points on this line. All right, so we got a point A, a point B, and a point C. And we can also have like a cursive L here. And so we can say AB with a line over it. We could say BC with a line over it. Or we could use a word and say line L. These all represent that same line right there. So you can use any two letters on the line to be the symbol for the line, or you can use the word line and a little, there's always a cursive L or some sort of cursive letter by the edge. It doesn't represent a point or anything like that. It's just another way to name a line. Okay, so then we look at a plane. A plane is a surface that extends. Okay, a plane is a surface that extends without end and has no thickness. A plane contains infinite many points. Okay, and so the diagram for a plane, we use kind of a parallelogram shape. And we're going to have points on it. All right. And so if we're going to use the symbol for that, we actually put 3 points together like this, no commas or anything like that, and that means plane ABC. Or we could say BAC like this. This represents the plane. Or we could use and say plane with a word, and then we have to use a cursive letter that's in the corner, and this was an R. So notice there's no dot by that R because there's no point to represent that. So cursive capital letters can represent planes, or 3 points on the plane can represent the plane. Now, what's important is that you need to remember that these 3 terms are called the undefined terms of geometry. I have to define these, and then everything else in the world of geometry is done from these 3 terms. I can build everything there is in the world from these things. So undefined terms of geometry, that tends to be a test question. List the 3 undefined terms of geometry, so you need to be able to list those. All right. Now, from these three terms, we get a few more terms. Okay, we get the term ray, opposite ray, and segment. So, a ray is a part of a line that consists of an endpoint and all the points of the line on the one side of the endpoint. So if we look at a diagram like this, this is a diagram, a picture of a ray, okay? And the symbol for ray is, in this case, AB. The ray on top always goes to the right. The first letter represents the endpoint. The second letter represents all the points going in that direction. So this one has to be written as ray AB. You never make the ray over the symbol point up, to the left, or any other direction. Okay, opposite rays are two rays that share the same endpoint and form a line. So in the picture of this one, the opposite rays would be ray BA and ray BC. Those are opposite rays. They share the endpoint B, and they go in opposite directions to form that line. Okay, a segment is a part of a line that consists of two endpoints and all of the points between them. So if I have this one here, I've got an A and a B, and so the symbol for this one would be AB with a little bar, or it could be BA. There wouldn't be any difference in these two right now. Later on in the semester, we'll actually make a difference between those two statements. All right, so these are the first 6 terms that we have in geometry. These are just defined terms. So these are defined terms. The other 3 were undefined terms, because these definitions for these terms come from the other words that we've learned. Okay? There are 4 postulates we need to learn today, and these go along with the definitions. So we want to make sure that we can know those too. Through any 2 points, there is exactly 1 line. Okay, so through any 2 points, there's exactly 1 line. So if we look at this picture here, line T passes through points A, those are capital A and a capital B, remember those represent points, A and B. And line T is the only line that passes through both those points. There's no other line you can draw that would go through both those points. Okay, so that's our first postulate. And basically, it's how we name a line. Any 2 points on that line, we'll make a line. So if you don't have a line through 2 points, you can put a line through any 2 points using this postulate. All right, postulate 1-2 says, if 2 lines intersect, then they intersect in exactly 1 point. So we have lines AE and line DB. Oops. That's not DB. DB. And we need the arrows on top. And they intersect in point C, right there. Okay? And so that just lets us know that anytime you have an intersection of 2 lines, you have a single point. Okay? So now we have 2 more postulates. Postulate 1-3 says if 2 planes intersect, then they intersect in exactly 1 line. So here we have plane RST and plane WST. There's no commas or anything, all capital letters. And they intersect at line ST. Remember, the intersection also is what do they have in common? And remember that planes go on forever. Even though we show them as rectangles or parallelograms that stop, remember that the planes go on forever, and so their intersection has to go on forever. Okay? And that's postulate 1-3, and so then we got postulate 1-4 through any three non-collinear points, there is exactly one plane. So points R, Q, and S are on plane P. And plane P is the only plane that contains them. Okay, so that's why we use 3 points to name a plane, because that's how we define a plane, through any three non-collinear points. Now, you may not know what non-collinear is, and so we'll just have a little discussion about that right now. So here we have a few more terms. So collinear points are points that lie on the same line. So every time you graphed a line in Algebra 1, you were doing collinear points. Co meaning same, linear meaning line. So if I do an example of this, I just need a line, and I need points on it. And remember, in geometry, we put letters by all our points. So non-collinear means points that do not lie on the same line. So here are 4 points. These are non-collinear. They do not lie on the same line. Or like I could even take this off and we could do this. This might even be better. D is non-collinear. A, B, and C are collinear, but D is non-collinear. All right, coplanar, points that lie on the same plane. So if I look at a plane here, points A, B, C, D. Those are coplanar points. Non-coplanar are points that do not lie on the same plane. So if I look at a plane here, points A, B, C, and I put point D over here, those are non-coplanar. All right. All right, so now we're going to do a little practice. All right, so are N, P, Q, and R coplanar? So you can pause the video and answer as many questions as you can, and then start the video back up when you're ready to see the answers and see how some of these work. All right, so you probably should have restarted your video by now. So are N, P, Q, and R coplanar? And that would be yes. These 4 points are all on the top plane of the figure there. Okay? And so most people tend to get that one right. So we have N, J, P, and Q. And this would be a no. And they are not coplanar. Points N, J, and P are on the front plane, and Q is not. Or you could say N, P, and Q are on the top plane, and J is not. So these are non-coplanar points. And then we have this last one here, which is N, M, and L. And most people say no, but the answer here is yes. And if we go back to postulate 1-4, it says, how many non-collinear points does it take to make a plane? 3. Do you see 3 points? I see 3 points. And so if I just plug another point here, maybe if you saw this picture, it might help you see the little diagonal plane going through the box. That one gets a lot of people, so watch out for that one. If you have 3 points and they're not in a line, they always make a plane. And you know exactly what plane they are because that postulate 1-4. Okay? And so it says name in 2 different ways the plane that contains F, G, D, and E. So we can go F, E, D, bed plane. We can do D, E, G. We can do GED plane. Well, that might be the plane you get if you can't get out of high school, the GED plane. All right, so we got lots of little planes here. So any 3 letters of these in any combination, we'll be able to name the plane. All right, are planes A, B, D, and E coplanar. So if you got 4 points, you got to look at them. A, B, D, and E. And a lot of people might say no on this, but I'm going to say yes. And the reason why, again, is that, again, look at this. It's got a little diagonal plane. The reason why this one works is because this line AB and DE are parallel, and so those points kind of line up. So there is a diagonal plane there. And so that is a yes, they are coplanar. Okay, watch out, don't get fooled by that one. Are B and H collinear? Well, I'm not even going to look at the picture because that's always going to be a yes. Because of the postulate we learned, through any 2 points, there is a line. So if you have 2 points, you got a line, so they have to be collinear. Now, C, H, and E. Now, that's not 2 points. I have to look at that one. So I got C, I got H, and I got E. Well, every now and then somebody tells me they can draw a line through those 3 points, and they do something weird like this. And last time I checked, that's not a line, that's a curve. So this would be a no. Okay, so that's some practice for you. See how you did on those. If you got those wrong, don't erase your answers on your notes. Go back and write why you got them wrong, because you're doomed to make the same mistakes if you do not correct and write what you're doing wrong. So these questions, 1 to this 8 through 15, would be yours to do tonight and that you can practice on. And then when you come to class, if you have any questions you're not sure, you can ask, and we will go over those if you need to. And that represents the end of the first lesson.